Hello everyone, myself Ankur Patel, and today in this sixth session of projection of solid, we will continue our practice with problems of prism. In the last session we have discussed an example of square prism. Today we will take an example of hexagonal prism. So let's start with the example. So the given content of the example is a hexagonal prism, side of base 30 mm, axis 60 mm long, is resting on one of its bases on HP, such that its axis is inclined at an angle of 45 degrees to the horizontal plane. Draw its projection when the axes are inclined at 30 degrees to the vertical plane. Now in this example, the solid is hexagonal prism, having base 30 mm, axis 60 mm long. It is resting on HP, and the inclination of its axis with horizontal plane and vertical plane are given. So here the condition with HP and VP both are given. So we can say that the example is going to be done in 3 different stages. So now we have to derive the first stage. So if you want to derive the first stage, we have to find out the condition of resting of the hexagonal prism. So this hexagonal prism is resting on HP on its base edge. So it is resting on HP on its base edge. Now whenever the solid is resting on HP, to derive the first stage, we have to assume that the base and the top face of the prism should be parallel to the horizontal plane, perpendicular to the vertical plane, and axis should be perpendicular to the horizontal plane, parallel to the vertical plane. So by assuming this condition, we are going to draw the first stage. So first of all, draw the XY reference line. Now here again we are going to use the first angle projection method. So if we are using the first angle projection method, top view will be below the XY reference line, front view will be above the XY reference line. And right now it is the prism is resting on HP. So we have assumed that base is parallel to HP, perpendicular to VP. Top face is also parallel to HP, perpendicular to VP. So we will draw the top view first, and as you know that the top view will be the hexagon. So starting with the top view, so draw the hexagon. Now here this hexagon showing the top view of its base and the top face. So now we have to indicate the top face corner and the base corner. So the side length of the hexagon will be 30 mm. This will be the top face corners and the base corner. So A, B, C, D, E, F is the base, and let us say that P, Q, R, S, T, U will be the top face. So this will be the top view. Now we have to derive the point of the axis. For that we have to join the opposite corners of the hexagon. So join the opposite corners. The intersection of the opposite corners will gives us the top view of the axis. Now we have to draw the front view, and to draw the front view we have to project all these corner points vertically upwards towards the XY reference line. So project these points. Now this will be A dash, B dash, C dash, F dash, and D dash, E dash. This will be our base. Okay, and base will be a line because we have assumed a base perpendicular to VP, parallel to HP. Now the axis height is 60 mm. So first of all we have to draw the side edges of the prism showing the axis height. So draw the side edge having height equal to 60 mm. So if we will take the side edge equal to 60 mm, the axis height will be equal to 60 mm. Now join the another side edge from this point also up to this point. So here we will P dash, Q dash, this point will be R dash, U dash, and this point will be T dash, S dash, and this will be our top face. So now you can see that the top view will be the hexagon and front view is a rectangle. Now the prism is resting on HP. So to derive the second stage, we have to take the condition of the prism with the horizontal plane, and here it is given that its axis is inclined at an angle of 45 degree. Now you can see that the side edges A, P, Q, B, CR, FU, DS, ET, all these side edges are parallel to each other, and it is also parallel to the axis. So the angle of the side edge will be equal to the angle of the axis. So right now we will derive the angle of the one of the side edge. Let us take the side edge DE. Now here you can see that the base edge DE is on XY reference line. So we can say that the base edge is on the HB. So the resting condition will be satisfied. Okay, so it is resting on one of its bases on HP. So now you can see that the base edge DE is on the horizontal plane, and this side edge the side edge DS and ET is inclined at angle of 45 degree. So if the side edge DE and TS is inclined at angle of 45 degree, the axis will be inclined at angle of 45 degree also, because the side edges are parallel to the axis. Now we have to copy this figure over here, and if we want to copy this figure over here, what we have to do, we have to draw these lines, the line of the base and the line of the top face from this point and this point, and perpendicular to this line. So draw the line like this, having length equal to this length. You have to measure this length from the first figure using the rounder. Okay, now connect these 2 points. This is A dash, B dash, and P dash, Q dash. So we have copied this figure here. Now we have to mark the side edges CR and FU. Okay, so for that we have to measure A dash, F dash, C dash from A dash, P dash, and we have to mark the point over here. Same U dash, R dash over here, and we have to connect these 2 points like this. So this will be C dash, F dash, and R dash, U dash. So now we have copied this figure over here by taking the angle of the axis equal to 45 degree. If you will measure the angle of the axis, see here the axes are hidden by the side edge CR. So the axes are not visible in this figure, but it will be overlapped by the side edge CR, and axis length will be equal to 60 mm. Now we have to draw the top view. So to draw the top view, first of all, what we have to do, we have to draw the locus from FU, AP and ET, BQ, DS, and CR. Now we have to draw the projectors from the top face and the base. So draw the projectors from the top face like this. This will be P, Q, R, S, T, U. So P1, Q1, R1, S1, T1, U1. Now we have to project the base also like this. So this will be the projector of AB, CF, and DE. So here we will get A1, B1, C1, D1, E1, F1. Now to draw the top view, we have to derive the position of the observer. An observer is going to observe this figure from this direction, upward to downwards. So you can say that the top face is nearer to the observer. So in the plan, the top face is going to be visible. So first of all, draw the top face, and PQRSTU is the top face. So draw the top face, PQ, QR, RS, TU, U, and UP. Okay, so top face is going to be visible because it is nearer to the observer. Now you have to follow this procedure whenever you are drawing the front view and top view in the prisms. In the second stage, if you are drawing the top view, you have to follow this sequence. First of all, you have to draw the top face, which is nearer to the observer. Then after, you have to draw the side edges, and then after, you have to draw the base. So follow this sequence. So now we will draw the side edges. You can say that the side edges are AP, BQ, CR, DS, ET, FU. By applying the rule of intersection of the visible and hidden outlines. That means two visible line will never intersect and two hidden line will never intersect. So connect A1, P1, it is going to be visible. B1, Q1, it is going to be visible also. C1, R1 is going to be visible. Now SD is going to be hidden. S1, D1 is going to be hidden. Okay, so it is hidden, but over here it is not going to be visible up to D1 to Q1 because it is overlapped by the side edge BQ. T1, E1 is also going to be hidden because it is not going to be visible, and as per the intersection rule, this line is going to intersect the visible outline over here, so it is going to be hidden. Now F1, U1 is going to be visible, So all these are the side edges. Now we have to draw the base edge. Starting from A1 B1 is going to be visible, B1 C1 is going to be visible, C1 D1 is going to be hidden, D1 E1 is going to be hidden, E1 F1 is going to be hidden, and F1 A1 is going to be visible. So this is the final top view. Now we have to derive the axis also. So for that we have to take the projection from this point over here. So this will be our axis 1 2. Now we have to derive the third stage, and in the third stage we have to take the condition with the vertical plane. So here it is given that draw the projection where the axes are inclined at an angle of 30 degree to the vertical plane. Now here it is given that axes are inclined at an angle of 30 degree to VP, not the plan of the axis. So first of all we have to draw a line inclined at an angle of 30 degree, and on this line we have to take the true length of the axis, and true length of the axis will be equal to 60 mm. So you can measure this length 60 mm, and you have to mark these points over here with true length 60 mm. Now we have to draw the locus from this point. Now measure the plan of the axis. So plan of the axis is 1 2. So measure this length on the router, and by taking center at this point give an arc over here and connect these points. So this will be the plan of the axis set at an angle of beta. Okay, so this will be the 1 2 axis. So we have plotted this plan of the axis over here at an angle of beta, Now what we have to do, we have to copy this same figure over here with reference to 1 2, with reference to the plan of the axis. So try to copy this figure over here with reference to 1 2. So this will be our top view with axis makes an angle of 30 degree to the vertical plane, but the plan of the axis will be inclined at an angle of beta. That we have to find out, because right now the true length of the axis and plan length of the axis are not same. That's why we have to find out the angle beta. Now we have to draw the front view. Give the name of the points A1 B1 C1 D1 E1 F1 P1 Q1 R1 S1 T1 U1, same as in this figure. Now we have to draw the front view, and to draw the front view we have to take the projections. So draw the locus from PQ, RU, TS, AB, CF and DE will be on the XY reference line. Now step by step draw the take the projections from the top view. So this will be A1 dash, B1 dash, C1 dash, D1 dash, E1 dash and F1 dash. This will be the projection of the base. Now draw the projection of the top face. P1 dash, Q1 dash, R1 dash, S1 dash, T1 dash and U1 dash. Now again we have to follow the same procedure. Now the position of the observer will be over here in the direction of this arrow. So you can say that the base is nearer to the observer and top face is away from the observer. So A, B, C, D, E is the base, it is nearer to the observer, and top face is away from the observer. So right now the base is nearer to the observer, that's why in the elevation the base is going to be visible. So draw the base visible by using the visible outlines. So A1 B1 dash, C1 dash, D1 dash, E1 dash, F1 dash to A1 dash is going to be visible. Now again we have to follow the same procedure. First of all draw the base as a visible outline, then after draw the side edges, then after draw the top face, because right now the base is nearer to the observer. In this figure the top face is nearer to the observer, so we have followed this procedure. First of all we have drawn the top face, then after we have drawn the side edges, and then after we have drawn the base edges. Okay, but in this the base is nearer to the observer, so in the elevation base is going to be visible. Now we have to draw the side edges. So A1 P1 is going to be visible. We have to apply the rule of intersection of the visible outlines and the hidden outlines. That means two visible line will never intersect and two hidden line will never intersect. So A1 P1 is going to be visible. Then after B1 Q1 is also going to be visible. C1 R1 is going to be visible. D1 S1 is going to be visible. Now you can see that E1 T1 is going to be hidden because this line is intersecting the line of the base edge over here, so it is going to be hidden. F1 U1 is also going to be hidden. Okay, now we have to draw the top face. So top face edge PQ is going to be visible, QR visible, RS visible, ST is going to be hidden, TU is also going to be hidden, and PU is also going to be hidden. So this is our final front view and final top view in the third stage, having axis inclined at an angle of 30 degree to the vertical plane. So this is it for today. Thank you for watching. See you in the next lecture. Till then, take care.